All right, so here we are, bottom of the third page on 1.1 through 1.4 notes, and we're asked to solve a system of linear equations. So a system just means that we've got at least two equations here, and so a system is more than one, and we're looking for where the solution is, and so what xy value makes both of them true at the same time. Sometimes you'll hear this referred to as being solve these simultaneously. And you got three different ways of solving a system of equations. You can graph it, which is um, a nice option. The difficulty with graphing is that sometimes um, it's difficult to find out exactly where two graphs will cross. Maybe they cross at a fraction or a decimal, and it's just or some irrational number, and it's just too difficult to see where they are. So this one's a little unreliable. Other than that, we have substitution. Um Substitution. And substitution can be very useful. That's probably the one that we'll be using the most throughout this year, because we'll be setting some linear and quadratic or cubic functions and trying to figure out what their solutions are. And substitution can be pretty useful in those cases. And the one that maybe you're the most used to right now is elimination, or combination, sometimes as it's referred to, combination. All right, and so we're going to use substitution and elimination here in this review. I did go ahead and graph this first one. So 3x plus 2y equals 12, and 4x minus 3y equals 11. I did go ahead and graph those on GeoGebra just to kind of, if you would graph those lines, there's the red one, or sorry, the blue one is 3x plus 2y equals 21, so it's right here, and then the red one is 4x minus 3y right here, and you can see pretty clearly that they intersect right at 5, 3. And so graphing again can be a solution, but it just isn't always the most reliable or most exact. So we know that our answer on this one is going to be 5, 3, and so I'm going to kind of write that off to the side to make sure we're doing everything correctly. We should end up with, actually, let me get a little bit further away because we'll need that space right there. We know answer should be 5, 3, so we can kind of test ourselves to see if we're doing this correctly. And let's start with elimination. With elimination, what we're going to do is multiply both sides of an equation by something until we get to where we can add the equations together and eliminate a variable. If we were to add them right now, we would end up with 7x minus y equals 32, and that didn't eliminate anything for us. So that's really not a useful first step. Instead, we're going to go through and multiply and looking for where we can eliminate something. And so as I'm looking at it, you could either eliminate for x or y, but I'm seeing that the y values are positive on the first equation and negative on the second, so this might be the easiest one for me to eliminate with. So I'm going to multiply the top equation and the bottom equation to get these y values opposite of each other. And it looks like the easiest number to get to is going to be 6. So it's positive 6 and negative 6 y. Now, what do I multiply the top by? Well, if I have 2y and I want to get to 6y, I need to multiply the top by 3 and 3. That gives me 9x plus 6y equals 63. Now the second one, actually I'm going to go ahead and switch colors just for clarity. And the second one we're going to multiply by 2. So 2 and 2. So that gives me 8x minus 6y equals 22. So I multiplied the top equation by 3, both sides by 3, and the bottom one multiplied both sides by 2. And now I've got two new equations. And they really are the same equations as they were back up here. They're just in a little bit more useful form now. And if I add these together, well, 9 plus 8, that's 17. So 17x, and 6y minus 6y, that's 0. If you really want to write plus 0y, you can, but that's 0 times anything gives us 0 here, equals, and so what's that going to be? 85. All right, we divide, so that's 17x equals 85. We'll divide both sides by 17, and we get that x is equal to 5. Once we're here, we come back up to the original equations, either one of them, and we're going to plug in x. And so 4 times 5, that's my x value that we just got, minus 3y equals 11. That's 20 minus 3y equals 11. I'm going to subtract 11 from each side and add 3y. Maybe we shouldn't do it all at once. So 20 equals 3y plus 11, then subtract 11, and we get 9 equals 3y, and y equals 3. Make sure that you write your solution together, and so x comma y, so 5 comma 3, and look at that. That's exactly what we thought our answer should be in the first place. So we solved that one kind of both with graphing and by using elimination or combination. So 5 comma 3. The next one's going to be substitution, and it's set up very well for substitution because we already have a variable that's solved for. And if you didn't have a variable that's solved for, that'd be okay. You just need to go through your algebra until you can get one of the variables by itself with a coefficient of 1. And now that we know what x is equal to, it's equal to 3y plus 6, we're going to take that x and what it's equal to, and we're going to substitute it in for the other x in the other equation. So rewriting that top equation, we'll have negative 2 times something minus 6y equals 24. And that's something that we're going to substitute in. Instead of the x here, we're going to put in what x is equal to. And we know that it's equal to 3y plus 6. All right, now we've got one variable, and now we can just work on through and solve. So distribute our negative 2. We have negative 6y minus 12 minus 6y equals 24. Combine our like terms. We have negative 12y minus 12 equals 24. Add 12 to each side, so negative 12y equals 36. And lastly, divide by negative 12, and we have y equals negative 3. Once we have that negative 3, we come back up and plug it into either equation. This one looks a little more useful to me, and so let's plug that in over here. We've got x is equal to 3 times, what was our y value? Negative 3, just plugging in our y value we just solved for, plus 6, again using that equation right there. X equals negative 9 plus 6, so x equals negative 3. And again, don't forget to give your solution in as an xy. So negative 3, there's our x value, comma, negative 3, there's our y value. And there we go. Hope that was helpful.